Hello, everyone. My name is Tita Chaudhary. I'm the social scientist, low carbon smart mobility at QTRIC. Thank you, everyone, for joining us on the second day of second Zero Emission Bus Conference. Today, I'm joining you from Edmonton, Alberta. And I would like to recognize or acknowledge this land as Edmonton is located in Treaty 6 territory within the Métis homeland and Métis Nation of Alberta Region 4. We acknowledge this land as a traditional territory of many First Nation, such as Cree, Dene, Nakota Sioux, Anishinaabe, and Blackfoot people. Before we begin our session, some virtual logistics. At the below your screen, we are having live transcription in both English and French. There should be an option there. If you don't see it, please refresh your screen. We want to make it a very engaging session today, so please share your questions on the side. And without any ado, I would like to introduce the panel discussion topic today. It is Autonomous Bus Transit-Related Pilot Program Efforts Across Canada and Globally. On our panel, we have Mr. Marco Croin, Director Canada of Ricardo Rail today. Some of you have heard Marco yesterday. Thank you for joining us today, Marco. And Marco has more than 20 years of experience in railway business on a global scale. He started at Deutsche Wagenbau, which was later taken over by Bombardier Transportation, leading an independent certified testing facilities for railways. Afterwards, he was responsible for global standardization in headquarters, managing engineers for locomotives and production optimization. Thank you for joining us today. Our next panelist is also Kathy Wilson, who will be presenting after Marco. She's the Senior Vice President of Parson Rail and Transit Solution, with 23 years of experience in the rail and transit industry, with successful track record of achieving results, driving organic growth, strategic development, financial performance, operational excellence today. Kathy will be sharing her knowledge, experience, and vision on this panel. So let's begin. I would pass my virtual mic to Marco.
Thank you so much for being here at QTRIC's conference. Currently, I see page 7. Yeah, thank you so much. So today I want to talk about autonomous bus operational potential that are besides the passenger transit, as autonomous buses are not only for passenger capacity experiences there, but they can do a lot of other effects as well, where you can have a much more efficient operation in your bus operation overall. So I want to give a few points on the next slide, which I might be able to do by myself. Here we go. So today I want to talk about the autonomization of buses, which will run then as well with the same technology as autonomous buses for passenger will operate, that you can use this system for parking, recalling, for automatic charging, for automatic stabling, washing, servicing, vaulting. There are probably many more topics, but I want to focus on a few ones where you just can be more both safer on the operation, but as well more efficient on saving time, money, labor, but as well reducing overall costs by avoiding any accidents that can occur on the depot. And I would like to start with a short movie, if you could bring it up. Thank you. And I need to go to the, yeah, thank you. So that was a fabulous demonstration project by the RATP, the French operator in around Paris. They did a demo testing about fully automated parking. So that saves a lot of time. In this case, you have seen, still a driver because it was a demonstration at the beginning. And that was more than 5 years ago where they started this one with quite a good success rate, up to still level 3. That is a little bit easier because no passenger are um, can have severe accidents or whatsoever. So the safety level is a little bit lower than on roads or on mixed traffic somewhere. The technology that was used is with video cameras, some localization measures, perception sensors, initial measurement units, 3D mapping. So that's pretty much the standard that we use in AV systems there. They were not up to sensor fusion during this time, but they were able to optimize the available space while parking. It's as well a lot for assistance drivers tasks. So much easier to go in the parking spot, avoiding any kind of damaged rear mirrors or bumpers whatsoever. So that was quite a great success on this demonstration project. I would like to show the next movie, please.
And there the autonomous bus appears. Full autonomous with no intervention for any human driving.
The bus that you see is a 12-meter electric. It will park here during the night, and in the morning when the driver is arrived again and signs in for his mission.
Thank you so much. And the next slide, please. I think that is a great example as it is focusing on operation. What can bring technology for the operator? And having these three examples of parking, recalling, automatic charging as well, and washing, it's just right away what I believe operators are looking for. It is depot. It can be a fenced area. Technology used in this case is where lidars, stereo cameras, global navigation satellite systems, and again a national management unit. So nothing super fancy. This is again what all the systems are using these days, but it's as well always the integration, how to use it in the yards for these specific cases. And if you can demonstrate these ones in pilots, I think it's a big step forward. So my final movie will come on the next one, please. Thank you. And I can go to this page here. So that's a fairly old project, more than 20 years ago in 1998 in the Netherlands, the so-called Phileas project, which had multiple new technologies. So not only the fully autonomous driving, in this specific case, already safety integrity level 4, so the highest one, which means that you can run really in any kind of environment and condition. So the system was designed around this highest safety level with the technology called free range on grid. That means that they have embedded magnets on the road in order to have a much higher accuracy for navigation system. They have a triple redundant fail-safe architecture from their vehicle control system. As you have seen on the beginning, there were like crabbing maneuver, so all wheel steering that gives a very nice and actually fast repeatability of embarking to the platforms. This specifically case had as well hybrid propulsion solution with a recuperation, and they were built as single and double articulation. So really a lot of technologies combined. They were running actually as well in service operation, both in Netherlands and in Turkey for some years. And I want to stress out that is already 20 years ago, where a lot of companies started around the globe with this technology. So a lot of is already now tested and can be used in service operation for these specific cases then, as you may want to define. As well, a lot of other companies, and there you can find movies as well on all of these, little slides that I'm showing here. Daimler-Benz in 2016 had a really great system in Schiphol Airport. Scania did a lot of trials, MAN buses, Volvo I've just shown, but as well Alexander Dennis, Iveco. So if you want to watch more, just Google these names, go to YouTube or somewhere, or ask myself. I can show you a lot of more material. They typically show the same thing: a bus driver not moving the steering wheel, demonstrating the capability of the technologies then. Same as well, the famous CRRC tram that you may know has an optical detection system of colored lines on the road. It's more like a tram type on rubber tired system, so a multiple articulated system there, but as well capable of doing manual, like going around obstacles. Many Asian companies, Baidu, Kinglong, CRRC Bus, then Turkish company, which we have seen yesterday as well from Karsan, for sure BYD, New Flyer, they have all done their test trials on those systems. So it's really starting being ready to deployed by our OEMs here. What I want to show a little bit on the potential is that you need a lot to prepare such systems from designing a safe systems, which means from all the powertrain attributes, you need all technical requirements in a system laid out in order to do at the latest step the testing, validation, verification of these requirements in order to achieve the required safety level. This is the process that we typically use in order to achieve this one, which is both the system hardware and the software that needs a lot of high quality and redundancy embedded in the system. On top of these typical technical requirements, you need as well the customer usage profile, some field data in order to meet all operational aspects then as well. As well, we can here see in this example a Ricardo fully autonomous system, 2018 Lincoln MKZ testbed. These days, I rather say any technical university can build their autonomous vehicle. I think it's known technology, what to do, how to do. It's a little bit trickier to get the certification in order to understand what it means, how to certify a system. Luckily, we have already many regulation, many standards that you can use. One of the famous one is the ISO 26262 one. What Ricardo has done as well is taking a lot of standards from the railway industry. Often we can use the Senelec standards like the EN 5126 to 129, as the rail industry is running since decades with CBTC systems, fully automated driverless solutions. And this kind of safety standard we can implement as well for product certification of the autonomous buses, as acting as an independent safety assessor. Another nice example on bus optimization potentials is in a complex holistic optimization consideration. So to see where your bus is operating, in which kind of environment, you can do a lot of optimization. A few examples I've shown on the parking, washing. What you can do, excuse me, as well is creating a virtual city environment in order to have a kind of digital twin, which enables you way more data and you can optimize another step forwards of your entire system. What we do as well is simulation of traffic data. If you want to integrate traffic lights into your system, if your city has such systems, you can use further communication, whether it's camera systems, voice system, and other data into your system for a fully integrated system. And I think we have heard previously as well some presentation about the adaptation of vehicles' energy propulsion strategy for charging on specific route plans, which gives then the full potential on autonomous systems then as well. Finally, what you need to do in order to implement autonomous buses is having a clear strategy. So I want to say that you really have to set up your objectives when you want to do like a pilot project and want to prove something. Within the strategy, defining these requirements and objectives is key, as you want to validate your objectives on the pilot phase, meaning you have to lay out already your final system, how it should meet these requirements. Out of these ones, there's the derivative of the technology that just follows what and how to meet. There are, standard systems in place, but that goes back to what kind of environment you have. Obviously, GPS system doesn't work in some garages, so you may need other signals. In winter condition, you have special constraints on a camera system. They don't work all the time in bright light on winter, snowy condition. And you have to consider, obviously, the kind of operation, which goes whether it is simple things like speed, capacity of people. They all affect the safety system and the regulation, how you do a certification of the system. Taking this into cooperation, I think we have a good potential in order to do implementation of more pilots and hopefully more in-service operation systems soon. Thank you so much, and I'm looking forward to our question after Kathy's presentation.
Thank you so much, Marco, for the presentation. I think this is very important, especially with autonomous vehicle, buses, transit. There are so many components together, and certification is so important because there are so many stakeholders involved when it comes to safety and training. So we will be having a lot of questions around it. Thank you for your presentation. I will pass on the microphone now to Kathy. Kathy is our second panelist, as I already introduced her, and she will be presenting now. Thank you so much.
There we go. Good afternoon, and thank you for the introduction, Tatash. It's my pleasure to join you today and to share the panel with Marco. I've had the benefit of knowing Marco for a few years now, and I appreciate very much his leadership in the industry, in transit innovation, research and development. It's always been encouraging to me that we have such leadership here in Canada. And interestingly, Marco and I live in the same neighborhood. So we have had some exciting conversations recently regarding the advancements in North America and the influence of Europe and Asia on transit here in Canada. Next slide. So when I thought about the topic today, autonomous pilots specifically, I wanted to try and expand beyond a discussion of shuttles and consider how close are we actually to full-size autonomous bus operation and what would help us get there. Marco's touched on a few things about safety and designing pilots. There certainly are various levels along the spectrum to autonomous vehicle operation, and I wanted to touch on a few things, including assisted driving features and functions. Autonomous shuttles certainly get a large part of the attention, which is good. They're absolutely a needed element of our transit ecosystem. However, there are benefits to assisted driving functions. You saw a little bit in some of the videos that Marco showed that can help improve capacity in bus lanes and in maintenance and storage facilities that really warrant some continued conversation. And lastly, I think we're all really aware of the resource challenges that we're having here in Canada right now. And I believe that we can learn from other sectors and tap that knowledge base of individuals and companies and organizations that have already deployed autonomous systems into operation, and specifically in rail. Next slide. So there have been multiple pilots, autonomous vehicle pilots, and about 15 small ones here in Canada for shuttles and vehicles. But unfortunately, they haven't necessarily led to larger procurements for transit agencies. And I think that's causing maybe a small level of frustration in the industry. And so I would suggest that maybe we step back and take a more holistic view of the pilots that we've completed and where we can take lessons learned. And there's 3 here on the screen that had very clear and specific defined objectives. And the technology was really the enabler to those objectives and trying to solve the problem that was identified. Specifically, they were looking to improve safety over human operation, definitely increase efficiency and time savings and kind of accuracy in the activity that was being performed. So I think it's really important to clearly define the pilot objectives. I think that sounds easier than it is to do, but I think clear objectives for your pilot will really help you expedite into an implementation easily. and be a key success to transitioning into an implementation. Next slide. I thought it was worthwhile to consider what the rail market could offer us in terms of autonomous bus and shuttle pilots of the market when contemplating how to plan for and design pilot programs and then move into an implementation. In rail, new technologies are often cut over into operations rather than being tested the way that some of the shuttle pilots have been done for a period of time. Rail obviously has fully automated passenger systems and autonomous features for operation. An example here is Toronto, the implementation of the communication-based train control system on our subway lines, specifically Line 1. It's almost complete. And the trains operate for a large portion of the line in a driverless mode. So because autonomous buses and vehicles still, I think, is a relatively new market in North America, I think it can be quite difficult for us as an industry to find the experience and the knowledge base to bring those technologies into our operations. So I look often to rail for some assistance in the areas of operations, safety, pilot design, integration, system assurance, and system safety. Next slide. I think that the concept of operations is a key first step when you're contemplating a transition to a new fleet type, and in this case, an autonomous fleet. So we heard last night from Anne-Marie Carroll as part of the QTREC conference, the networking dinner last night. She talked about not having a lot of options to turn to when York Region started the journey transitioning to electric buses. They sought outside consulting support and they engaged QTREC. I think the introduction of new technology into an operation, it affects so many elements of the operation that need to be considered early in a concept, such as power, your range, fleet strategy, timing, facilities and upgrades, performance and training for all of your staff, and any changes in your operation for maintenance. So passenger rail really provides a resource of people and an experience base to draw upon for bus and autonomous shuttle programs. You heard Marco say that many of the same safety principles for a concept are easily transferable. And the same thing for the selection of technology. Next slide. So the concepts for safety certification and the development of the safety case, and also protection against cyber intrusion, can all be drawn from the rail industry. The standards that we've applied in passenger rail have been developed and applied in the industry to create confidence in what we're designing and our design processes. So when we look for guidance on how to provide safety assurance for autonomous operation, I think we can use the principles and the experience derived from rail projects in real applications here in Canada to support looking for ways that we can expedite from small scale trials to much larger pilots and increase and expedite the implementations here. Next slide. I think the key, my observation for Canada seeing really meaningful pilots that result in procurements will happen when we have an integrated multi-agency coordination. Much like we've started to see fair coordination across the regions and municipalities and operations, where there are key connections of services and shared facilities, I think that's where we're going to see the expediting of autonomous pilots when we have the same approach. We'll probably need a greater Toronto region as a Toronto region to coordinate our needs assessments, our pilot designs, our technology choices, incentives, and just even looking at the size of pilots, trying to create and frame larger pilots in shorter timeframes so that we can share the conclusions. So I think running 2 shuttle pilots in isolated areas won't give us the same program level of information that we need in order to get to procurements and implementations. QTREC, thankfully, is playing a key role in the coordination and the advocacy for all parties and stakeholders to come together. Next slide. The integration of new technology into an operation, specifically an autonomous vehicle, I think would really benefit from the development of standards and working groups to collectively prepare best practice. So I think this is an industry need, and QTREC has certainly been at the forefront of that activity. I think it would be helpful in the industry if we could see an exercise similar to what APTA and PREA have done in the United States, providing best practice guidelines and templates for pilots and procurements in a standardized manner so that mid-size and smaller agencies that don't maybe have the large engineering and operations teams could benefit collectively and procure collectively. I think it would be really helpful to consider whether one of the agencies in Ontario, since that's where the majority of the autonomous pilots have taken place, could provide that leadership and give that to support to the industry to create a center of excellence that other agencies could draw upon. We are seeing this. I've chatted with AC Transit. There is a similar strategy happening with AC Transit in California for bus electrification. They're one of the largest agencies and are far enough along in their bus pilot program that they've started documentation for training purposes and all that they've learned through the change management process, and specifically what their operators and maintainers needed to learn in the facilities. So they've started to share that with other transit agencies, and they've mapped out a strategy for their facility to be used as a training center for other agencies in California. Next slide. Lastly, I wanted to come back to the concept that autonomous vehicles are often thought of in the context of shuttles for last miles or designed for area type services in small areas, and answer the question about whether we really are going to be able to get to full-size bus automation in the future. I think we will, and I think the key success factor will be the application of systems engineering and the methodology of systems assurance, which is used extensively in passenger rail. As agencies move through the various levels of automation, whether that be considering automated assistance on BRT vehicles and the benefits that capacity can provide, so upgrading your BRT to an automated BRT, or last mile type shuttle services to reach other modes of transit, integration with all the adjacent operations is going to be really important. So the technology itself, I don't think, is the obstacle. Rather, it's the use of a systematic approach to design and the integration and commissioning of new technologies with others that exist in the transit system. So as linear infrastructure is designed and built out with new vehicle technologies, I think the V model for systems engineering will become a key practice in the autonomous and other automated bus and shuttle developments. Next slide. Thank you.
Thank you so much, Kathy, for the presentation. There are so many interesting points that you already mentioned, like to start with, like taking examples from rail, like I'm glad that Kutrick is on the same page when we're building this whole systemic approach of like taking a step back and then defining the objective. That is such a key component to it. And I'm glad that you mentioned that and you brought this up. So I think now that we have both our completed presentation, if Marco wants to be on the stage as well, and I can start with the Q&A. So we do have a question from the audience already. And either Marco can take this from your experience in deploying buses in other global areas, and then Kathy can also add to this. So how do you mitigate the risks around data security for AVs? Any improvements of note in the industry? That is a very important question. I think everybody wants to know about the data security and standardization around it. So.
Yeah, I can start on this question. Definitely, cybersecurity is a critical concern of many, which is good that is already embedded in safety function, in an like independent safety assessment. It is one part in order to allow and in order to drive, operate fully autonomous systems at all. The rail industry is having typically their own backbone network on CBDC systems, fully redundant, in order to allow always correct communication between the central control and the vehicles or train systems. We have to see now how it is deployed on autonomous systems. I believe there will be as well always a central control. That's typically an easier way of doing the operation. It's the safer way because you always want to have a supervisory system, and it's more complex if maybe it's easy with 1 or 10 vehicles, but if you have a growing fleet, it becomes more complex, and you want to do as well many more aspects like fleet management. The central control on the communication enables then a safe threat against cybersecurity, and that detects and protects then as well all data that goes along with it, whether it's for the control, whether it is for maintenance data, or whether it is a second network system for non-safety critical systems then.
Kathy, would you like to add something to that point as well?
Sure, thanks, Tadesh. I think I would, in addition, adding to what Marco said, look to one of the specific IEC standards, 62443. I think I had it on one of my slides. As Marco said, Rails had a good experience with designing for cybersecurity through safe design, and that would be a good place to start to look. There's a roadmap in that particular standard for general security.
Yeah, but for sure, like there are so many, like the United Nations cybersecurity has that list that all the OEMs follow, and we've gone through that. At the same time, that's a very important thing that both of you mentioned about the taking some lessons learned from Rail of having a central operation. And right now, from what I understand, the central operation in AV shuttle or buses, correct me about the buses, but in AV shuttle works as a problem-solving unit, not like a complete observation. So anything that you want to add in terms of how that can be improved from the central operation standardization point of view?
Yeah, so the typical central operation system fulfills multiple functions. On the one hand, it's one of the key supervisory system. So first of all, giving the order of each vehicle or train, having like a directive, from which point to which other point does this vehicle shall go, whether it's a fixed schedule, whether it's an on-demand system, whether you want to do like adding fleets on demand or just, on specific hours. This is kind of the first role of a central control, where you can do already an optimization of the system. Typically, what we are looking for is always capacity of a full system and use the assets, as best as possible. You don't want to drive empty vehicles, hot air around the city, right? So you want to design your system around having the best suitable system for your passengers, that the waiting time is as less as possible. So sometimes you want to run as well less occupied buses to this specific area because you have maybe specific thresholds for waiting times then as well. Second is the safe communication of the central control that gives all the signals in order to having knowledge about which vehicles is at which place, having no accidents or whatsoever, and having the possibilities to stop vehicles, to do manual interaction. And third is the typical communication with passengers, whether it's starting a video camera outside, inside, talking with passengers when there is any incident that may occur then.
Great. Thank you so much. I think I'll direct a question to Kathy, and if you want to shed some light on what kind of infrastructural standardization are required to integrate the new technologies that we're talking about, if you want to talk about that.
That's a good question. I wanted to just add to what Marco said before we moved on, that I think it's helpful to offer that systems assurance is a risk mitigation methodology, and that's been applied in rail and is absolutely applicable for autonomous bus and shuttle operation. But I think the important takeaway for all of us is that application, for a project is not only for the product, it comes at the very beginning of the planning stage. So the transit agency will be looking to apply a systems assurance process right from the very beginning of the planning and the concept of operations for the pilot and the deployment, and then it carries over into the implementation as you transition all of the fleet. So
And
It's
that
not
roots
something
to
that comes in at the back end, right? It really is important to have it at the very, very initial stages.
yeah, and that roots to the thing that you both mentioned about having an objective first defined. Why is the pilot and what is the pilot for before even going forward with it? Yeah, thank you so much for both of your inputs on that. So we're moving on to that question that I asked before. I'll just repeat it again, which is what are the infrastructural standardization do you think, or both if you think, are required?
I might refer that question to Marco. That's not really my background from a civil perspective, although certainly it's a combination of development with the ministry and the industry.
Yeah. Often when you talk about rail system in the signaling world, they are often proprietary systems. So there's often not easy to interchange signaling systems. However, in the automotive world, that's kind of a no-go. They need and want to be as open as possible. So automotive world have started with standardization of some of the interfaces in order to allow a much easier way from a central control system towards communicating with vehicle systems. As it goes beyond this as well, that we will have the vehicle-to-vehicle communication for platooning. This already, in place as well, and that moves ahead with standardization as well, because you don't want to have like only one fleet running, very close. We can imagine that works fine for like a BRT system in order to increase the capacity. But if, as an operator, you want to purchase your vehicles from different supplier, then you need to think about how is the communication on the autonomous systems. It becomes more and more complex. It is possible with the way currently the automotive industry is running with doing a lot of standardization on these interfaces. What I want to stress out, that's maybe easier to start with little steps like this in the depot automatization, because you have a much better controlled environment on your own assets. You can much better work with different suppliers that they have to adopt the same standard as you have purchased for the central control, for example.
Yes, thank you. I'm going to move on to another question that was asked by our audience. How important is it for Canadian stakeholders to benchmark against leaders in this field from Europe, China, US, and other countries?
I can.
Yeah. Go ahead.
Yes, Kathy, if you want
That's
to.
a great question. I think there's not been enough for sure in the industry. There is absolutely a gap in our ability to look comparatively at the conclusions from various pilots. There's a lot of standalone information, but there's not been a lot of collective conclusions from pilots and from just the sharing of data and agencies. I mean, it's still a very new market, and so it's not a reflection of that. That's not a priority. I just think that that's the next step that has to happen, is that we would absolutely benefit from other regions that are farther advanced in terms of completing pilots, larger scale pilots, and moving on to infrastructure over and above just the rolling stock, as Marco said, into depots. And there's so many other potential opportunities for automation in transit service and the management of transit service that we should be collectively looking to. And that's why I referred to that. There's some interesting developments that transpired in the United States. I found the PRIA exercise quite innovative a number of years ago. The regulatory, the academic environment, manufacturers, and public sector agencies all got together and said, the standardization of some of our documentation, the standardization of our specifications, our operations requirements, and just our standards generally for safety and security would benefit from a commonized specification. And a service, autonomous bus or automated bus, and also shuttles would also benefit from, I think, some standardization. And Marco just referenced that on a small scale, but we need a lot more coordination with other regions and agencies, and that requires a lot of support. For it's not easy for agencies to get that interagency international coordination other than through conferences, but also some development programs. It's hard for agencies; they're busy operating, as opposed to trying to do peer exchanges. Although there certainly in rail, there's been a lot of peer exchanges, and certainly in the CBDC market, right, Marco? When you were introducing a new technology, they really had to rely upon peer agency exchanges and transfers of knowledge.
Yeah.
Absolutely. I think what's really helping here is as well the two Kutrix programs, the National Smart Vehicle Demonstration and Integration Trial, with more like low speed autonomous shuttle system. But it is autonomous system. So it was a great start with a lot of engagement, many stakeholders. Most important, a very good discussion. What do we want? What do we need in Canada here? What are our specific constraints? The harsh winter condition. So I think that formed already a great community around setting the objectives, defining requirements. And then later on as well, the autonomous connected electric and shared big data trust. Even it's more focusing on big data, but it as well had, at least at the beginning, some regulation about safety of autonomous systems there. That all helps, I believe, and I hope that we can, bring some good results out of these projects then soon.
Yes, thank you so much. Yes, Kutrick is trying to doing the job to bring these stakeholders together, because these conversation has to be openly done between all of them, and it cannot be done in separation. And a lot of transit agencies are sharing that lessons learned from their pilots that they have done. As a social scientist, I think there's one question I wouldn't end this without asking is what kind of, because one of our goal for a lot of transit agencies to increase ridership as well. So what kind of awareness marketing strategies do you recommend for transit agencies, cities to adopt in order to increase riderships? Because it is autonomous, it is not always driverless. So that messaging is quite important in a lot of contexts. And going back to Kathy's point on the objective being correct. So any Marco and Kathy, anything that you want to share on that?
Sure. I think most important first is safe operation, zero accidents on passenger. This is paramount. That goes beyond everything, whether it's with the driver or driverless. So we have to consider this one always, I think, as highest priority. Second, I believe, is the efficient system, and that goes in hand about your question about capacity. How can I, increase capacity? How can I maximize my asset usage by smart systems? And there is the autonomous system a key driver, because you can do much easier on-demand system. You can switch between a scheduled routing against then later on demand system. You can optimize the system then by integrating the charging technologies. Even if you have opportunity charging, this costs you money as well. This is asset that you want to use. Same with the depot charging. So you can do much smarter system by this increasing the integration of all these systems. And the third point is the passenger experience. So you want to make it as easy, as pleasant, less waiting time as possible. at the end, you want to have more like a unique driving style that, oh, I remember I was in Toronto running on the system. It was so smooth, beautiful. I didn't have to think about anything like looking at each station, whether I'm already at my destination, I have to hop off, or no, the system tells you, hey, it's now your time to get off. So I think these are the three key areas: safety, capacity with efficiency, and passenger experience then that can help in order to increase the ridership.
Perfect. Thank you so much. Yeah, I would like somebody to wake me up, in fact, if I'm dozing off after work in the shuttle. But Kathy, anything you want to add?
Sure. I'm not an expert in generating travel demand, but I am a transit user, and I think the question you were asking is, as using a shuttle project as an example, how do we encourage usage, so that the shuttle's not running around, it's not empty? Because we've got the pilot up and running, how do you ensure that that the route is being used to, and often the shuttles take you to other transit agencies, so like a Metrolinx or a commuter rail or something like that. I think it's a variety of things. It's just generally, how do you encourage individuals to take transit? And there's a number of factors. There can be, cost factors like implementing less parking at multimodal stations, charging for parking at multimodal stations, time, so express service. So there's a lot of mid-size and smaller transit agencies that have implemented express services for their buses to compete with going to certain major employment centers. If the express service is faster and more reliable, with GPS and this than driving, there's a variety of factors I think that can influence. Also, I think just general change and behavior management. Many agencies in Canada have initiated student programs, encouraging behavior at a young age to utilize transit. And that's an interesting, I think, strategy as well. So I think there's a variety of things that can be done to encourage people to use them.
Perfect. Yeah. No, I totally agree. Like, I can hear safety, obviously infrastructure, accessibility, making sure building micro transit systems and efficiency around it. Thank you so much. I know we have a few more questions, and we will be having a networking session just right after this. So please join us at the networking session. Thank you so much, Kathy and Marco. And I know that a lot of transit agencies and a lot of audience has more questions who can reach out to you. I would like to end the session today by mentioning that if you have missed, I'm thrilled to share that CUTRIC has been named the National Planning Service for Infrastructure Canada's Zero Emission Transit Fund. We are excited to support transit agencies and municipalities plan and their way for zero emission fleets. To learn more about it, contact CUTRIC via email, or you can also visit us on our website. Thank you so much, Kathy and Marco, and see you at the networking session. Have a great rest of the day.
Thank you.
Thank you so much. It was a pleasure.